Have you ever felt like time is slipping through your fingers? Do you remember when you were a child and summer seemed to last forever? Now, the years seem to fly by. This feeling, though subjective, raises fascinating questions about how we perceive time. Is time actually speeding up, or is it just our perception of it that's changing? To unravel this mystery, we must first differentiate between objective time and subjective time. Objective time is what we measure with clocks and calendars. It's a constant ticking away at a steady pace. Subjective time, however, is our personal experience of time. It's fluid, influenced by a myriad of factors from our age and emotions to our environment and experiences. Understanding this distinction is crucial to comprehending why our perception of time can vary so dramatically. While objective time marches on, our subjective experience of it can stretch, compress, and even seem to vanish altogether. One compelling explanation for the feeling that time speeds up as we age lies in the intricate workings of our brains. Professor Adrian Bejan proposes that as we age, the rate at which our brains process visual information slows down. This slower processing creates the illusion of time accelerating. Imagine a film reel. A younger brain processing information quickly sees more frames per second, making time seem to move slower. As we age, our brains process fewer frames, resulting in the sensation of time flying by. Intriguingly, the concept of time speeding up isn't limited to our subjective experience. It's a phenomenon that has fascinated scientists and philosophers for centuries. The way we perceive time can vary greatly depending on our activities, emotions, and even our age. For instance, a minute can feel like an eternity when we're waiting for something, but it can fly by when we're engaged in something enjoyable. This subjective experience of time is just the tip of the iceberg when it comes to understanding the complexities of time. Einstein's theory of relativity, a cornerstone of modern physics, proposes that time itself is relative and can be affected by factors like gravity and velocity. This groundbreaking theory revolutionized our understanding of the universe. According to Einstein, time is not a constant, unchanging entity. Instead, it can stretch and contract depending on the conditions. This idea was a radical departure from the Newtonian view of time as an absolute, unchanging backdrop to the events of the universe. One of the most mind-bending predictions of Einstein's theory is time dilation. This phenomenon occurs when an object moves at a significant fraction of the speed of light. As the object's speed increases, time for that object slows down relative to a stationary observer. This means that if you were traveling in a spaceship at near light speed, you would age more slowly compared to someone who remained on Earth. This effect has been confirmed by experiments involving high-speed particles and precise atomic clocks. Time dilation suggests that time slows down for objects moving at high speeds relative to a stationary observer. This has practical implications for space travel and our understanding of the universe. For example, astronauts traveling at high speeds in space would experience time differently than people on Earth. This could potentially allow for long-duration space missions without the astronauts aging significantly. It's a fascinating concept that challenges our everyday understanding of time. This means that time is not absolute but rather flexible, a concept that has profound implications for our understanding of the universe. The flexibility of time also opens up intriguing possibilities for the future. Could we one day harness this knowledge to travel through time or explore distant galaxies? While these ideas remain in the realm of science fiction for now, the study of time continues to push the boundaries of our knowledge and imagination. As we delve deeper into the mysteries of time, who knows what incredible discoveries await us? Section 5. Gravitational time dilation, time warps. Einstein's theory also predicts another fascinating phenomenon, gravitational time dilation. This concept suggests that time passes slower in stronger gravitational fields. In essence, gravity warps time, causing it to flow at different rates depending on the strength of the gravitational pull. This effect, though seemingly bizarre, has been experimentally verified. Atomic clocks, incredibly precise timekeeping devices, have been used to demonstrate that time passes slightly slower at sea level, where gravity is stronger, compared to higher altitudes. Section 6. The role of routine in time perception. Beyond the realm of physics, our daily experiences also play a significant role in how we perceive time. The way we structure our days, the routines we follow, and the activities we engage in can all influence our sense of time's passage. As we age, our lives often become more routine. This is not necessarily a bad thing. Routines can provide comfort and stability. However, they also have a profound impact on our perception of time. We wake up, go to work, eat dinner, watch TV. These activities form the backbone of our daily lives. Each day we follow a similar pattern, and this predictability can make time feel like it is moving faster. The days blend together in a predictable pattern. When each day is similar to the last, it becomes harder to distinguish one day from another. This can make weeks, months, and even years seem to fly by. This repetition can contribute to the feeling that time is speeding up. When our days are filled with routine activities, our brains don't need to work as hard to process new information, making time seem to pass more quickly. When our experiences lack novelty, they don't leave a lasting impression in our memories. Novel experiences require more cognitive processing, which can make time feel like it is moving more slowly. As a result, time seems to slip away unnoticed. To counteract this, it can be helpful to break out of routines and seek new experiences. By doing so, we can create more memorable moments and make our perception of time more expansive. Engaging in new activities, trying new hobbies, or traveling to new places can all help to slow down our perception of time. These novel experiences require more mental engagement, making time feel richer and more substantial. Reflecting on our day, writing in a journal or meditating can also help us to be more mindful of our time. By paying attention to the details of our daily lives, we can make each moment feel more significant. Ultimately, the way we perceive time is deeply personal and influenced by our daily routines and experiences. By being mindful and seeking out new experiences, we can enrich our lives and make our time feel more meaningful. Section 7. Experimental Evidence, Muons, and Atomic Clocks. The idea that time is malleable might seem like science fiction, but it has been confirmed by numerous experiments. One of the most fascinating pieces of evidence comes from the study of muons and atomic clocks. These experiments have provided concrete proof that time can indeed be stretched and compressed under certain conditions. One compelling example involves muons, subatomic particles that decay rapidly. Muons are created when cosmic rays collide with particles in the Earth's atmosphere. These muons have a very short lifespan, typically decaying in just microseconds. Muons created in the upper atmosphere, traveling at near the speed of light, should decay before reaching the Earth's surface. Given their short lifespan and the distance they need to travel, it seems impossible for them to make it to the ground. However, experiments have shown that many more muons reach the ground than expected. This surprising result puzzled scientists for a long time. How could these particles, which should decay so quickly, survive the journey to the Earth's surface? This observation can be explained by time dilation, a concept predicted by Einstein's theory of relativity. Time dilation means that time slows down for objects moving at high speeds. For the muons traveling close to the speed of light, time essentially stretches out, allowing them to survive longer from our perspective. This phenomenon has been confirmed by placing atomic clocks on high-speed jets and observing that they tick more slowly compared to clocks on the ground. These experiments collectively demonstrate that time is not a constant, but a variable that can change depending on speed and gravity. The implications of these findings are profound. They not only validate Einstein's theories, but also open up new possibilities for understanding the universe. Time dilation is not just a theoretical concept, it has practical applications in technologies like GPS, which must account for these relativistic effects to provide accurate positioning data. The study of muons and atomic clocks continues to be a rich field of research, offering insights into the fundamental nature of time and space. As we delve deeper into the mysteries of the universe, the study of time dilation and its effects on particles like muons will undoubtedly lead to even more groundbreaking discoveries. The journey of these tiny particles through the atmosphere is a testament to the incredible and often counterintuitive nature of our universe. Section 8. The interplay of factors influencing time perception. The perception that time is speeding up is the result of a complex interplay of factors. Our aging brains process information differently. Einstein's theories of relativity reveal time's flexibility, and the routines of our lives affect our subjective experience of time. It's not just one element, but a combination of these factors that shapes our perception of time's passage. Understanding these influences allows us to appreciate the multifaceted nature of time and its profound impact on our lives. Section 9. Conclusion. Time's subjective dance. While objective time marches on relentlessly, our subjective experience of it remains a fascinating and deeply personal phenomenon. The feeling that time is speeding up, particularly as we age, is a testament to the remarkable adaptability of our brains and the mind-boggling nature of the universe we inhabit. Though we may never fully unravel all the mysteries of time, exploring its complexities enriches our understanding of our place in the cosmos and deepens our appreciation for the precious and fleeting nature of our existence.